All right, time for another example. Let's find the relative extrema of this. We'll start by just taking the first and second derivatives. F prime of x will equal 20x cubed, and the derivative of 30x squared will be 60x. Let's go ahead and find the second derivative. F prime prime of x will equal 60x squared minus 60. Okay, now, by the way, we could find inflection points as well. Let's go ahead and look at the previous example again. If we wanted to, we could have found an inflection point by setting 0 equaling 18x, 0 equal the second derivative. So that means that x is equal to 0 would be an inflection point of that graph. Anyway, let's continue with the example we were doing. We want to find minimum and maximums, so that means we need to set this equation equal to 0. So we get 0 is equal to 20x cubed minus 60x. We can pull out an x, leaving us with 20x squared minus 60. So one of our zeros is x equals 0. And the other two will be 0 equals 20x squared minus 60. Add the 60 over, divide by 20, and we get 60 equals 20x squared, or 3 equals x squared. So x equals positive or negative square root of 3. Those are our three potential points. And so what we need to do now is go ahead and figure out where those are increasing and decreasing. I've already gone ahead and plugged in these values into the original function. So our 3 points are 0, 0, square root of 3, negative 45. And we've also got negative square root of 3, negative 45. So those are our 3 points. We need to tell if those are maxes or mins, and we do that by plugging in the x value into the second derivative. So if I plug in 0 here, I get this becomes 0, minus 60 is negative. So that means that this one is a maximum, a relative maximum. If I plug in the positive square root of 3 here, I'll get square root of 3 times square root of 3 is 3. 3 times 60 is 180. 180 minus 60 is positive 120. And again, I'm doing this kind of quickly, but you can just do this in your calculator. Anyway, that's positive, so that means this is a relative minimum. If I plug in the negative in here, it becomes positive negative square root of 3 times negative square root of 3 is positive 3. And again, we get the same thing. 3 times 60 is 180. 180 minus 60 is 120, which is positive, which makes this a relative minimum. Let's find the inflection point. We do that by setting this equal to 0. And then we just solve. So add the 60 over, divide by 60. And so I get that x equals positive or negative 1. So that means those are inflection points for us. And what that means is if you plug those back into the original functions, we have inflection points at 1, 25, or negative 1, 25, excuse me, and positive 1, negative 25. So those would be our inflection points. And again, if you're asking me where I got the 25s from, I just plugged 1 into the original function and then negative 1 into the original function. And in fact, I believe that should be negative 25 for both of them. So I must have had a mistake there. So negative 25 for both of them, because you plug in 1 here, or negative 1 here, negative 1 here. It's going to be negative 25 either way. By the way, if we wanted to find the full inflection point here, just plug 0 into the original function. The full inflection point would be negative 0, negative 2. So you just plug it in. All right. I actually think the second derivative test is fairly straightforward once you get the hang of it. If you have any questions, please let me know. We'll do another example, our final one for this section, in the next video.